Hello, everyone. I'm John Coleman from ApocatastasisInstitute, an Institute for the Humanities and Alternative College and High School here on New Milford, Connecticut, USA. Tonight, I'm being joined by Professor Adam Myers as we make our way through Euclid's Elements today, looking at Proposition 20. We've had a few weeks with very, very small, very short propositions. This one's a little bit meatier, but we've no better guide than Professor Myers. And, much like the Arabic and Latin and Greek mini series, I suppose, that we've picked up lately, as well as the history one, the reason we do these Euclid Today presentations is to remind you and to remind myself that we do offer mathematics classes and tutorials here at the Institute. So, whether you have a child in grade school or you yourself happen to be in college and need some tutoring, or whether with Vandana Rataria or Adam here, or you just want to brush up on your math in terms of general ed, please do contact us here at the Institute and we will set you up in the private sessions. With that being seen to, Adam, welcome. Thank you for making time. And what you explained to me before the recording is a very busy day. And take it away.
All right, so let's go ahead and get into this proof. This proof is a little more complicated because it requires a little bit more reasoning, but it is still, I would say it's still straightforward. We don't need to do any constructions or anything. All right, so what we're going to be doing is showing that the sum of any two sides is greater than the remaining one. And this actually is a really important proof. It's called the triangle inequality. This is used all throughout mathematics, in particular a field called analysis. So the triangle inequality ends up being incredibly powerful, especially when you add it with the concept of absolute values. You can prove a lot with just the triangle inequality. So this is an objectively useful fact. All right, so let's go ahead and get into it. I've hyped it up quite a bit. I almost promise we'll see it again throughout this series. I would be shocked if we don't. All right, so we're going to start off with ABC, which is the little yellow triangle. We're going to start with that. And we're going to construct the magenta triangle on top, ADC, by taking the side AC and extending AB by that length. So DA and AC should be the same length. And using those two, we then join D and C, as we see in the image. So from the get-go, DA and AC are the same size. Okay? Very important that DA equals CA. All right. Once we have that, we're now going to start reasoning. Since they equal each other, as we proved way long ago, back in proposition 5, the two angles, the two corresponding opposite angles have to match. So ADC and ACD both have to be equal. Since we're setting their sides to be equal, those corresponding angles have to be equal to each other. Okay? And since they're equal to each other, the fact that BCD is clearly larger than ACD means that BCD also has to be larger than BDC. Is that clear? I hope that's clear. That's I would think the most challenging part of this proof is seeing that bit of a leap because it's not obviously explained in the text. So with that, we can then realize that because we have that, because BCD is greater than ACD, BD must be greater than AD. Okay? Hopefully that's clear. And therefore, it's greater than BC as well. Since BDC is smaller, BC has to be smaller than BD. That's very important. Okay? But since DA equals AC, if we take the sum of BA and AC, which is going to be BD, that is going to be greater than BC. And that's the core of the proof. We're left as an exercise to show that this is true for the other sides. You just simply repeat this process. You do the exact same thing on each side, and without loss of generality, you will show that the sum of any two other sides is greater than the same, greater than the other side. All right. Any questions?
No, thank you, Adam. Thank you for that. And I do apologize for the delay there. Sometimes these buttons don't cooperate. No, no questions on my end. And if people do have questions about it, if you look at this website, which is a very easy one, I will put it in the description, you will see there are some additional pointers down below.
Mhm.
Also, on this website, besides the glorious use of magenta and yellow, there's also on the right of the screen, you can see these footnotes, basically, which will take you to some other supplemental and referential things in the text where they're making
Yeah.
those connections there. So
Those are the
the
justifications for each of the steps.
good, the justifications. Thank you for that.
Mhm.
Good. All right. Very good. So again, Professor Myers here is available for high school and college tutorials, and we have Ms. Vandana Rataria for the younger children with mathematics and handwriting as well. Let's see. Adam and I next month or next week, which will be next month, we'll have our monthly naturist talk, and we'll get into that and see what's in the works for that. And then just finally related to this series, Euclid today, we do offer this semester, going into this summer term, uh, Greek, introductory Greek. And so you'll get a handle on the alphabet, on reading some basic sentences, on Greek grammar, and things of that sort. I say that because Euclid's Elements was originally written in Greek. So with that being said, Adam, I hope the remainder of today is a little bit calmer than the first stretch. And thank you especially for your insights and your instruction.
Nope, my pleasure.